Hi grade 9s. So this is just a short video on gradients just to kind of help you when you're doing the exercise this afternoon. So this is where we ended up the previous time I taught you on gradients. So we were just deciding, is this graph increasing? Is it decreasing? And would the gradient then be positive or negative? Okay, so now what we want to do is we want to actually work out the gradient. So we say m is equal to the change in y over the change in x, okay? And the change in y is given to us if we look at the change in y. So what is that change in y? Remember, the y-axis is over here. It goes from -1 up to 0, which means that the change is 1, okay? But because it went up 1, it means it's positive 1. And what was the change in the x-axis from 0 to 3 was 3 spaces that it moved, okay? And remember that when we move right, that is the positive direction of x. And if we move left, that's the negative direction of x. If we move up, that's the positive direction of y. If we move down, that's the negative direction of y. So both of these were a positive direction. So the change in y was 1 over the change in x was 3. So there you have your gradient for the first one. Let's look at the second one. So here, from 2, we went down 2 spaces. So in the y direction, we went down in the negative direction, and we moved 3 to the right in the positive direction of x. So if we consider our gradients again, the change in y over the change in x, we've got -2, that's the change in y, over 3, which is the change in x. And there you've got your gradient. Okay. The next one, we've got number 3 over here. So here what we do is we again do the exact same. Pause this video and try this on your own quickly and see if you come right. Okay, so in the x direction, we moved from -5 to 0. Because we moved right, it's positive 5, the change in x, okay? And then because from there, we move up 1, which is the positive direction of y. So our gradient is going to be the change in y over the change in x, and that gives me 1 over 5, okay? And this makes sense because this graph is going upwards, which means that we would have suspected that our gradient would be bigger than 0, and that is the case. So if we look at the next one, we've got this horizontal line, okay? So now what happens is this is where y is equal to 1. But at this point, y is also equal to 1. At this point, y is also equal to 1. Even at this point, y is also equal to 1. So doesn't matter what the x value is, the y value, let's say that's 3, 5, -7, the y value will always be 1, which means that this line, the equation is y is equal to 1, okay? So that's our equation. And for a horizontal line, all that you need to remember is that its gradient is always equal to 0. So whenever you have a horizontal line, the gradient is always equal to 0. So let's look at the next one. Now we've got a vertical line, okay? So what happens with a vertical line is now the x value stays 1 the whole time, okay? So let's say we've got this coordinate as 1, 0. That's our x-intercept. And let's say we've got this point over here. Let's say that's -3. So we've got 1, -3. Okay, so the change in x was 0. There was no change. And the change in y, okay, from, let's say, from -3 up to 0, that's 3 units. But now what's going to happen is if you put it into your change of y over change in x for the gradient, you are going to see that you are going to divide by 0 because the change in x, there was no change in x. So that means that's 0. And that's why the gradient of a vertical line is undefined. So this is undefined gradient. Okay, you don't have a gradient for this line. Okay, see if you come right with the questions for homework, please. Here it is again in case you missed it.